Oh my word, there's so many people in here for our final two acts. In a moment, I'll introduce Noam Chomsky and two amazing people to speak alongside him. And then we're going to close out, as is tradition, with the pretty incredible president of Portugal. It's been an incredible 4 days. I hope everybody have you had a good time? It's been remarkable. The father of modern linguistics, Noam Chomsky, joins scientist, author, and entrepreneur Gary Marcus for a wide-ranging discussion on why the myths surrounding artificial intelligence are so dangerous and why we should not rely on AI to save us all. Please welcome to the stage Noam Chomsky and Gary Marcus of Robust.ai in conversation with Jeremy Kahn from Fortune.
He's here.
Oh.
Hi, Noam. Thanks for joining us. And Gary, thanks for joining us. A lot of people think we're living in the golden age of AI. There's a lot of hype around generative AI, these systems like DALL-E and Stable Diffusion that can create amazing images just from text prompts. There's also a lot of discussion about GPT-3, a system created by OpenAI, that can create long passages of coherent text, again, just from a small human-written prompt. A lot of people are very excited about where this technology is going. But no, my understanding is that you are not, that you are actually disappointed in where we are with this technology. Why is that? Oh, I don't know if he can hear us. There we go. Yeah, I am, indeed, yes.
Be efficient. One way is it's not strong enough, fails to do certain things. The other way is it's too strong. It does what it shouldn't do. Well, my own interests happen to be language and cognition, language specifically. So take GPT. There's Gary Marcus, others have found lots of ways in which the system's deficient. This system and others doesn't do certain things. That can, in principle at least, be fixed. You add another trillion parameters, double the number of terabytes, maybe you do better. When a system is too strong, it's unfixable, typically. And that's the problem with GPT and the other systems. So if you give a database to the GPT system, which happens to be from an impossible language, one that violates the rules of language, it'll do just as well, often better, because the rules can be simpler. For example, one of the fundamental properties of the way language works, there's good reasons for it, is that the rules, the core rules, do not ignore linear order of words. They ignore everything that you hear. They attend only to abstract structures that the mind creates. So it's very easy to construct impossible languages which use very simple procedures involving linear order of words. Trouble is that's not language, but GPT will do just fine with them. So it's kind of as if somebody were to propose, say, a revised version of the periodic table, which included all the elements, all the possible elements, and all the impossible elements, and didn't make any distinction between them. That wouldn't tell us anything about elements. And if a system works just as well for impossible languages as for possible ones, by definition, not telling us anything about language. And that's the way these systems work. It generalizes to other systems too. So the problem is, the deep problem that concerns me is too much strength. I don't see any conceivable way to remedy that.
Interesting. Gary, you've examined how some of these systems fail. Can you talk a little bit about what those sort of modes of failure are that you've discovered?
Sure. And usually also, Noam and I have had this interchange over the last few months where he tells me that I'm too nice when I'm negative about AI. In this case, there's a certain way in which I thought he was too nice. So he said that in the ways in which these systems are too weak, just adding more parameters, maybe that will help. And there I actually take a darker view maybe than Noam does. Some examples of the kinds of problems these systems have are DALL-E, if you tell it to draw a blue cube on top of a red cube, it might just give you a red cube on top of a blue cube. So one of the most basic things about language is that we put together meanings from the orders of words. This is an idea that goes back to Frege and even further. These systems don't understand the relation between the orders of words and their underlying meanings. Another version of this system, you say something like, draw a picture of a man chasing a woman, or draw a picture of a woman chasing a man, and the system is basically a chance. It really can't tell the difference. And it's not clear that just adding in more of the same, what people call scaling today, is actually going to help. I think that there's something fundamental missing from the systems, which is an understanding of the world, how objects work, what objects it's describing. There was another article that just came out on theory of mind and whether these systems can understand what you believe about other people. And there was failure on those kinds of things. There's failure on a system to understand something like, if I want some grapes, or sorry, I ask you if you have something, did you touch this glass? I can't remember the exact example. And you say, well, I had gloves on, so my finger, implying your fingerprints aren't there,
right.
And the system doesn't understand it. That was another benchmark that came out this week. So when DALL-E came out, Sam Altman of OpenAI said, AGI is going to be wild. Artificial general intelligence is going to be here, and implied that these systems are close to artificial intelligence. And scientists like me weren't given access. And in the last couple of months, we've been given access, and these things fall apart left and right. So yes, they can draw pretty pictures, but no, they really have a very shallow understanding of language. And then to Noam's point, if they have a shallow understanding of language, they're not really helping with the question that Noam has worked on all his career, which is, why is human language the way that it is? And what he's saying is, these systems could learn computer languages or languages that aren't like humans. They could learn anything. They don't do any of it perfectly, and they don't really tell much about why we're the special creatures that we are.
Interesting. Noam, I know you've sort of said that these systems are maybe good engineering, but not very good science at all. Can you explain what you meant by that, and why you think the science here isn't really valid?
Well, let's take engineering achievements. So I happen to be hard of hearing, so I can't hear most of what you're saying. I'm reading live transcription, captions. It's pretty helpful. I'm all in favor of it. It's achieved by brute force, no scientific interest, but it's fine. I'm happy with it. I'm happy with a snowplow that clears the streets, so you don't have to do it by hand. I don't see anything, I have no criticism of that. I think it's great. Sometimes engineering achievements can contribute to science. So a telescope, for example, allowed Galileo to discover things he couldn't have discovered without it. Well, that's fine. There are apparently some engineering achievements with the deep learning approaches that have been like a telescope. So they've apparently produced some helpful results with regard to protein folding, massive computation beyond hand computation. So that's good. But science is a different concern. You're trying to understand what the world is like, not how can I make something useful. Nothing wrong with making useful things. But the project of trying to understand what the world is like is different. So turning to Gary's point, I'm perfectly willing to concede that I've been too nice and thinking that if you add 1,000 parameters, maybe you'll get somewhere, maybe you won't. But my concern is different. If the system doesn't distinguish what's the actual world from non-actual world, it's not telling us anything. Just as in the case of the souped-up periodic table, the GPT systems and others like them can find superficial regularities in astronomical amounts of data and produce something that looks more or less like what their data was. But it can do exactly the same thing, even better often, with data that violates all the principles of language and cognition. So they're first telling us nothing about them. You might ask whether it's making an engineering contribution. Actually, in this case, I don't really see any. I don't see what point there is to GPT, except maybe helping some student fake an exam or something. But so it doesn't seem, it has no scientific contribution, doesn't seem to have any engineering contribution. So as far as I can see, it's basically a way of wasting a lot of the energy in California.
Right.
And inspiring.
Well, that's a good point. I want to bring Gary in. What do you think the dangers are here? I mean, if it's, you know, these are tools that are in some ways useful, is there a danger, though, in thinking that they're more capable than they are? Is there a danger in the hype? Gary, what do you have to say about that?
I think there's two kinds of dangers. One kind of danger here is that I think we're following the wrong path in AI, and the right path to AI, I think, is going to involve looking more at humans and doing the science that Noam is talking about. And so we're in this moment where we're at a local maximum. We have something that looks good, but isn't really as deep as we need it. And it's sucking the oxygen away from the field of cognitive science, looking at how humans understand language, how humans understand the world, because it's so much fun to play with these toys. And it's fine for people to play with the toys, but it takes away a lot of the energy. You know, young graduate students, if they have a choice between going into linguistics or a choice between working on GPT-3 and getting paid a lot of money, they're probably going to work on GPT-3. But I think it's short-sighted that we wind up with a technology that actually has a kind of short road ahead, isn't going to last as long as people think. And you look at the history of AI, there have been fads over and over again, expert systems and support vector machines that people in this crowd probably haven't even heard of, that were super popular for a while. And we need to have something that's more stable, and one more fad's probably not helping us. Then there's another kind of danger, which is the systems we have now, what they do is they perpetuate past data. They don't really understand the world. So for example, that means that they're sexist and they're racist. They're not built to be that way, but because they just copy the data that's there and don't have values about equality, for example, they perpetuate past bias. Another example is because they don't have models of the world, they kind of lie indiscriminately. Now they don't do that literally because they have no intention, there's no malice, but they produce misinformation, and it's going to completely change the world in the next couple of years. The amount of misinformation that troll farms are going to be able to produce and the cost of that is really, I think, going to be devastating to the democratic process. And so the fact that you have a system that kind of looks good, can make sentences that are grammatical, but make up stuff like, why is it good to eat socks after meditating? And then say some experts believe that it's good to eat socks after meditating because such and such. It all sounds plausible. You read it on a website when you're like falling asleep and you believe it. Well, now you can do this at scale. You can get your own custom version of GPT-3 for less than $500,000. So if you're a troll farm, that's a great investment, but it's terrible for society. So there's some specific dangers around it. Then there are lesser dangers, like a lot of people spent a lot of money on driverless cars, and it doesn't really look like it's working out. Like, maybe it'll happen in 20 years, but we're not going to have routine level 5 self-driving where you can type in a destination and go anywhere the way Musk has been promising it for 6 or 7 years. That's just not going to happen. There's been $100 billion put into that industry, and the money is wasted. I'm more concerned by the threat to the democracy than investors wasting their money, but it is another kind of side product of all of this.
Is there a danger also in sort of not understanding modes of failure? I mean, some of those things you've discovered recently when you have had access to these systems about the way in which they do not understand language. Is there a danger in sort of believing the hype and thinking these things are more capable than they actually are?
Well, I actually have a prediction. I think it comes out tomorrow in Wired for the year 2023. I predict that it's going to be the first year in which there's a death attributable to one of these systems, either because it tells somebody to commit suicide or somebody falls in love with one of these systems, but the system doesn't actually love them back, and they abandon it, or because it tells them to, mix Clorox with Drano and they drink it all. So people trust these things because they appear plausible, but it's kind of like a magic trick. What they're really doing, we haven't said this, is basically a version of autocomplete. Like in your phone, you predict the next word. GPT is really just autocomplete on steroids, but it gives this illusion that it's more than that. And if people get sucked in, then they can take bad advice from these systems. And I think we will see a lot of that next year as these things become widely distributed and cheap.
Interesting. Noam, I know you said you don't think there's been much contribution here. Do you think there's been sort of any contribution from these large language models to the actual understanding of linguistics, which is what you've devoted your career to?
I can't think of one single thing. I mean, I can give you an example of the kind of stuff that comes out. Just a couple of days ago, I don't follow the literature on this closely. I'm not like Gary. But a friend sent me an article from something called, I think, the Federation of Associations of Behavioral and Computer Science or something like that. It was a study, a massive study, in which the guy it was published in their journal. He had all of Reddit and a ton of other things in his database. All kind of supercomputers, and studying what you can learn about frequency of words and how important this would be for language understanding. And they gave one example that was really the chief achievement. They discovered that the word occasion is used much more frequently than the word molecule. And the reason they explained is because it's used in many domains, whereas molecules only used in a few domains. Who would have guessed it? That kind of contribution that comes out. If there's anything else, I've missed it.
Interesting.
I mean, these things can be useful. Like I say, basically what lies behind the live transcription that I'm using. So again, I don't have anything against snowplows. Happy to have them around. But they shouldn't mislead people, which indicating it for Gary's reasons and others, that they're making some kind of contribution to science. They're not. They're not helping us understand the world, and they can't, in principle, because they're too strong irremediably.
Interesting. And Noam, I think you've said when we were speaking before this that in looking back at the history of AI, that the purpose of the field was not simply to make better snowplows, that there was this idea of trying to actually understand human intelligence and then to build on that. Can you talk a little bit about, do you feel like the whole field's kind of gone awry here in focusing so much on these deep learning systems?
Well, I was around when AI was being developed and knew many of the people. The original goal was to use the capacities that had been developed in computer science, both technical and intellectual, because it was a major intellectual breakthrough, the theory of computation developed by Turing and others. The original idea was, let's use this technical, intellectual contribution to see if we can understand something about how humans think. You go back to the paper that initiated the field, Alan Turing's famous paper on 1950 paper on called Can Machines Think? Machine, of course, means program, not the object. Well, he was interested in seeing if we can understand what thinking is. You go to early pioneers in the field, Herb Simon, Marv Minsky, others. That was their goal as well. Can we learn something about cognition, thinking? Well, that's by now considered old-fashioned AI. There's various disparagements. And it was gradually replaced over the years by what Gary was just describing, playing with fancy toys. And it's understandable. I mean, I've spent most of my life at MIT. Take teenage kids and smart teenage kids, hand them fancy computers that can do all sorts of things, massive programming systems. It's going to be a lot of fun. When I got to MIT in the 50s, one of the ways that students used to have fun was by playing with a very elaborate electric railways, which you could do all kind of complicated things with. Well, 10 years later, in the 60s, when they started having these toys, no more electric railways. This was a lot more fun. You could do all sorts of things. Figure out a way to make the elevator run when nobody was running it, but running a program. And you can imagine what it's like. So it's exciting. You play with the toys. You can do a lot of complicated things. It does get intellectually interesting when you work into how the programming works, how the statistical analysis works, and so on. It's just not going anywhere. It may produce useful things like live transcription, but that's not very exciting. I mean, it's helpful, but not a real contribution to understanding the world. As far as understanding the nature of language or any other cognitive process, I literally can't think of anything that's been contributed.
And Gary, I know you've thought that there's a lot of things we do know about cognitive science that is being ignored sort of by the current enthusiasm for deep learning and ever larger deep learning systems.
Yeah, I look at what people are doing now, and I think, have they ever taken a class in linguistics? So in linguistics, you learn about the relationship between syntax and semantics, for example, and between those and pragmatics. And if you build a language production system, for example, in the classic way, you start with a meaning that you want to express, and you translate that into words. Or in language comprehension, you start with a sentence that you want to understand, and you translate that into a meaning. Well, GPT-3 doesn't do that, and people don't even notice that it doesn't do that. What GPT-3 does is it hears a sequence of words, and it predicts the next word. But let's say you want to talk to a user, and you know what you want to say. Well, GPT is like a wild bucking bronco. It's very powerful. It might produce something grammatically interesting, but whether it winds up giving you what you want is an entirely different matter. And if you want to extract from it a model of the world, it doesn't really do that. So there's this paper called Palm Saycan, I think, by Google, where they put GPT-3 in a robot. And it works like 3/4 of the time, and it's amazing. But a quarter of the time, it doesn't work. Now imagine that you want to put your grandpa in bed and you want to tell the robot to do that. And 3/4 of the time, it does that. And 1/4 of the time, it drops your grandpa. Like, this is not good.
Yeah. We don't want any dropped grandpas around.
So, cognitive science tells us that we want, for example, it's just a basic thing, but you want to map a meaning onto a sentence or the other way around. And people are like, I've got all this data, I don't need to do that. Well, no, you really do still need to do that. Another example is we have lots of knowledge. You go to college and read books, or when you're 5, you read books. You absorb verbal, symbolic knowledge from the world. And there's this funny politics that goes back 50 years about using neural networks versus a knowledge-based approach. It turns out the knowledge-based approach has some value, but it had some trouble, 30 years ago. So now we're doing all this stuff without knowledge, which means like you have all the knowledge in Wikipedia, and nobody really knows how to put it into these systems. And because they're statistical mimics, you ask a question like, who's the president of the United States? And they might say Donald Trump, because in their data set, there are more examples of Donald Trump than Joe Biden. Whereas you want to be able to reason and say, well, Biden is now the president, Trump was the president before. You want to use your understanding of sequences of events and time. And cognitive scientists think about this stuff. They talk about things like discourse models, putting together what it is that we're talking about, how we're talking about it. So there are lots of ideas. Another one that we didn't talk about yet, but which I learned from Noam, and which is really foundational, I know he learned it from Plato, is innateness, the idea that something is built into the mind. There's lots of reason to think that when we learn language, we're not starting from a blank slate. Noam has made this argument for years and years. I think it's still true. And the failures that we're seeing, for example, with DALL-E, and I'll tell you about one other, are showing you that if you start with a blank slate that just accumulates statistics, you don't really understand language. The paper I have yesterday, which I sent to both of you guys, shows the same thing in vision. So there's some models that label activities. So it can say, you're nodding your head, those people are sitting out there. You can do some visual labeling, and the myth is always the right things will emerge, which is kind of magic. It's like a Latinate word for magic. It will emerge when you give enough data to these systems that they will understand the world. So we built a benchmark based on what 10-month-olds do in the lab, or 4-month-old for some of the experiments, understanding basic physics, like things drop, or if they're hidden, you can still find them eventually. And these systems don't understand at all. Allen AI Institute and some developmental psychologists from Illinois and I published this paper yesterday. It's a complete failure of the empiricist hypothesis that if we just give a lot of data, that cognition will emerge. And developmental psychologists have done lots of work. Liz Spelke in particular, but many people, Renee Bayerjean, one of our collaborators on this paper, have done lots of work showing that children seem to have probably an innate sense of how objects exist in the world. Like, we don't start with nothing. Kant said we start with time and space and causality. He's probably right. We probably start with those things. And over, people keep pursuing this hypothesis that ignores the cognitive science around that and says, we'll just use all the data. And because it works like 75% of the time, they think they're making progress. But sometimes you make progress 75% of the way, it's not enough. We saw that in the driverless car industry, right? Getting close doesn't really seem to solve that problem. And that's what we're seeing here.
Right. And Gary, I know you have some ideas about how you would go forward. If today's AI, despite all the hype around it, is not delivering what we want, what would be a path forward?
So I have an article called Next Decade in AI, which people can read later in archive, but it points to 4 things. One is what we call neurosymbolic AI, which is putting together this tradition of neural networks that's popular now with the old-fashioned AI, and trying to find some kind of synthesis between the two, because they each have some value. The neural networks are good at learning from data, but they're not very good at abstract knowledge, and the old symbolic stuff is good with abstract knowledge, but not learning from data. So that's step 1. Step 2 is we need to have a large database of machine interpretable knowledge. So all of these things kind of fake their way through, but the knowledge is never rich enough and abstract enough. So like, that if I have a bottle, you can't see it, but if you saw me bring it up, if I knock it over, there's probably going to be water on this stage.
Right.
Even if you haven't seen this particular bottle in this configuration. You have very general abstract knowledge, and that's crucial, I think, to any real general intelligence. Then we can reason about things. We can make inferences about them, and we have cognitive models of the world. So right now that I've mentioned it, that this bottle is here even if you can't see it. And so you're maintaining an internal representation of the stuff that's out there. It might be imperfect, but you have a representation in your head of the things out there in the world, and you reason over it. These are foundational ideas in cognitive science, and they're not represented in current AI, and we're seeing the cost of that.
Interesting. Noam, do you think that what Gary's saying is probably the way forward? That some of these ideas about innateness should be incorporated into the way we think about AI systems?
I think those are good ways to proceed, but I also think that if AI wants to proceed, it should take into account what has come to be understood about the basis for acquiring our cognitive capacities, which of course do involve fundamental built-in innate properties. We now have some understanding of them, and even some understanding of why they're the kind that evolution would provide. We should recall that back in the early days, the days that I happen to favor myself, AI was basically not distinct from cognitive science. It was just one of the ways of approaching the problems of cognitive science, using achievements, great achievements that had been made both intellectually and technologically with the development of the theory of computability and the physical devices that were able to implement it. This was a great way to advance cognitive science.
Right.
As long as you were part of science, not when you're playing with toys or trying to impress science reporters and journals, but when you're pursuing the methods of science in the cases that Gary was discussing, taking into account the kind of discoveries of Liz Spelke, Rene Bayerjean, and others about the innate basis for our ability to maneuver in the world. If you're working on language and thought, which are virtually indistinguishable, then you look at what has been discovered about the innate basis for the acquisition of language on the basis of virtually no evidence, as has been shown by now in experimental work, a lot of it by the late Lilac Lightman, others, which show that a child just acquires language the way it walks. You know, it's just sitting there waiting to be triggered by some stimulation, then it all comes out. Well, you want to study introducing such understanding into the methods of AI could lead to carrying forward the earlier programs, which I thought were on the right track, of using the achievements of intellectual achievements, technological achievements as a way of carrying cognitive science forward in its effort to understand what the world is like, in this case, what our minds are like.
Great. Well, we're out of time, but I want to thank Noam Chomsky and Gary Marcus for coming here and debunking a bit of the hype around today's AI and also pointing forward to some ways we might be able to take the technology forward. Thank you very much, and thank you for listening.